Okay, so as last class we learned spherical refractive surfaces. Okay, what are these spherical refractive surfaces? The refractive surface is a part of sphere of refractive material. From the diagram itself, we understood already. We completed this part. Okay, the first diagram you can see this is having convex refracting surface. Okay, we are not talking about convex lens or convex mirror, but we are talking about convex refracting surface. That means this medium and this medium both are two different mediums. This may be chalo medium 1 and this one is medium 2. In that case, this will be a rarer medium and this is your denser medium. We can see this clearly. Even for concave refractive surface, we can see this clearly. This is your concave refracting surface. So that is how we understood and we drew the diagram. We understood what is the pole. It is same as a mirror and lens. We have already learned C is the center of curvature. If we supposed to complete this circle, and this will be your center of curvature. So that is called center of curvature. 3P, as P is your pole, so CP is your radius of curvature, and accordingly if you connect CP, AB, all these things lie on one line only. That is why it is called principal axis. Okay, so assumption, we already know all this, and a few of them we are going to take seriously. Ki bhai, aperture should be small. This aperture, or we can say diameter of this curved surface will be this surface, matlab this surface. Okay, this is going to be small. One more thing is there, which is like incident and refractive rays are making small angles. Matlab angle of incidence and angle of refraction, they are going to be small. They are going to be small. If they are going to be so small, that means our sin I can be written as I. Your tan I can be written as only I. So whenever these are small, no, we have one advantage when we do the proof and all. I can be considered as a sin I. It is approximately, and R can be approximately written as a sin R. So in place of like Snell's law and all, if we had to write sin I by sin R, we can write I by R, and that will be for our convenience, for the proof purpose only. So these are like assumption. We are going to take small. Even for tangent also, tan I is similar to I and tan R will be similar to R because the angles are smaller. Third thing we have seen, object is point size. In this diagram, you can see that we are going to assume this way only. You are going to see this in the diagram. Next page will be having diagram. So over there you will understand. Incident ray, whatever is coming from the left hand side, we are going to take always in this manner only, left to right. All the distance from the pole to the refractive surface, and always from pole only we take, no, like u is the like image object distance is considered as suppose this is your object and this is your pole, so this is your u, and it is in the direction, this direction, so it is considered as minus u. Distance will be u, but we have to do the sign convention. For to understand sign convention, understand that this is your pole, and pole can be considered as origin in the like a Cartesian system. So everything at the left hand side, it is acting as a x-axis, negative x-axis. So all the measurement you are going to measure left hand side will be negative. All measurement on right hand side will be positive. Upward will be positive h and downward will be minus h. So that we are going to consider. And this is your Cartesian system. Okay, give heading, which is very, very important now. Now onwards, we are going to prove. I'm going to show you two proofs or three proofs we'll do, but accordingly we can use for different things. Refraction at convex surface in the bracket from rarer medium to denser medium. And here we are going to use, here we are going to find for the real image, for the real image. Now you can see convex surface. That means we have to draw in somewhat like this, right? Refraction at convex surface. So this is our convex surface. Rarer medium to denser medium as it is given. All right. Then what is next? Next is we have to have real image. So when do I get real image? If it is inverted. And when for the convex surface, I would get real image, real and inverted. You remember when do I get this? Okay, it's completely fine. We will do that part later because we are not on the lens side. When we do lens, you will understand that in detail. Okay, now so you can learn like this only. Okay, this is your CP. E is the pole, C is the center of curvature. This is your principal axis. Please do not draw, I insist, do not draw your diagram small. Please draw the diagram little bigger. You are going to draw many things, otherwise you can wait for that. Here we are going to consider point object. This is your point object O. And when this point object would give me an image, so we have to consider two rays, right? One ray you can see that we have considered directly this one only, because as it is pole, with pole it is making zero angle of incidence is zero. So it is undeflected and it goes directly inside and it is meeting anywhere, wherever your second arrow is going to meet, right? But what about this? Rarer to denser. That means what do we need to do? We have to draw a normal at that. So actually, how do we draw? Okay, this is your surface, fine. This is your surface, and this is my principal axis, fine. Please consider this as a rough diagram. You can follow the top one, and at some point, I'm going to draw a normal at that point. Normal matlab 90 degree at that point. 90 degree at that point. So I'm going to give name as N, and I know that my ray is going from rarer to denser, rarer to denser. That means it is going to bend towards the normal. So it is not following this path. Instead of going into this path, it is bending towards the normal, towards, this is your normal, right? I'll change the color. Color is blue for the normal line. And suppose it has to go like this, but it is bending towards the normal, and that is how it is the refraction happens, and I'm getting image because two rays are meeting at one point will produce image at that point. So that is my image. This is my pole. And you know what? Normal at curved surface. Just try to understand this. If I need to draw normal for this point, it will be always passing through center. Normal at this point, suppose here I'm drawing normal, so it is again passing through this point. Normal at another point will passing through this point, and this is center. Always for the curved path, whenever we draw a normal, it will be passing through the center. So what about this? This normal is passing through this point. That means it is our center of curvature, and that is what in the above diagram also you would be able to see. So now we have angle of incident and an angle of refraction. Angle of incident is the angle between the normal and the ray, incident ray. And what about the angle of refraction? Normal and refracted ray. So that is your I and this is your R. Okay, first of all, very important thing is to draw this diagram. If you have not drawn properly, please, I insist that draw it again. With me only, it will be taking no time. Okay, and it will be your practice purpose only. You will be done with that then. Any diagram you will be able to draw, because we are going to draw this kind of diagram, plenty diagrams, minimum 6 diagrams you are going to draw like this manner. Okay, and if we draw, because you know what, whenever we consider a triangle, here so many right angle triangle we are going to consider for the proof purpose, and that point I need to have this 90-degree thing. Okay, one should be there. So if I needed to make one perpendicular on the principal axis, so you can see that we made this. Why so? Because we are going to use this for our proof. That is the reason we have taken, otherwise there is no other reason. And you know what, this M, point M and this P, they are very close. Okay, so actually we take measurement. Suppose what is this measurement from pole to the object? We know that it is the object distance u, but P and M are very close. Even for OM also I can take u because they will be very close. Okay, so these things we need to know for the proof purpose. Suppose I'm taking angle for sorry, this angle can be considered as alpha. Remember that for with object, we are in all the diagrams, we are going to take alpha. We are going to take alpha for object, beta for image. Beta matlab wherever you will be having image, that and your principal axis, obviously with all principal axis. What third left, because we want gamma also. Center of curvature, and that will be your gamma. I'm erasing everything, whatever I do. And this is your diagram, where PC is the center of curvature R. This OP is the object distance U, and PI is the image distance V. We don't write further. First of all, for at least one derivation, I'm going to show you how to write description. Full description we are going to write. Your which one is a refractive surface? So I can see that AP and another name is not given. So we are going to take A. Okay, over here it is point. This point is A. Fine. So let me take any number, any point. I'll take XY. Okay, XY. We are taking XY just for the naming sake. Okay, because this point is taken as A, so that's why I had taken this. So first point, A, P, oops, sorry, X, Y, X, P, Y, right? X, P, Y is a convex refracting surface which separates a regular medium of refractive index mu1 from denser medium of refractive index mu2. So here we can see that there is a surface XPY which is going to separate rarer medium and denser medium, which are having mu1 and mu2 refractive indices, right? And for this one should remember that we are writing description for our understanding. For CBSE people, it is not so important, but for state board, it is really important. They actually give marks, half mark for these long description, which will be half a page, and half mark for the diagram. And for CBSE, 1 mark will be for the diagram only. The description should be given only in a one line. One liner description is okay for CBSE. One line should be given, I guess. Yes. So let P be the pole, as whatever we discuss, that only we are writing, nothing else. C be the center of curvature. And R is equal to PC. B, the radius of curvature. Of this surface. Suppose a point object O is placed on the principal axis in the rarer medium. We have kept point O is placed on the rarer medium. Then what happened? We made like one arrow should be made so that we got one ray should be taken so that we got the image starting from the point object O, a ray OA. You can see a ray OA is incident ray. So a ray OA is incident at an angle. Angle of incident is I. So at an angle I. And what happens at point A? So refraction occur, and after refraction at point A, it is going to refract and it is going to bend because it is from rarer to denser medium. So a ray is going to bend towards the normal. So a ray bends towards the normal. What is the normal point? AC. AC is the normal, or we can say NC, better. NC is the like a normal, and it is going to move towards the normal and it follows the path A I, right? And two rays are going to meet at point I, and that is how we got the image I and the principal axis, right? After refraction, it bends towards the normal CN at an angle of refraction R. I'm going to erase this. To have beta, just a second. So we saw that it is after refraction, it bends towards the normal, right? So another ray, we want one more ray also, another ray, because two rays are going to meet, and at that point we get the image. Okay, so another ray is also had to be taken. So another ray, which was it? OP, right? Another ray OP is incident normally on the convex surface and passes undeflected or undeviated. Both are okay. Here we got two rays, two incident rays and two refracted rays. The two sorry, refracted rays meet at point I. So I is the real image of point object. One more thing we drew, and that is draw NM perpendicular to principal axis. So that was the full description which I told you. And we wrote only one time, and we are going to write only one time only for this purpose only, and that's it. So here we understood, okay, how it happens and all. Okay, in this case only we understood. Not again and again we are going to do. Okay, now let us focus on the derivation. Actually, what will be the derivation? This derivation will give us what thing? So this derivation is going to give me a relation between, sorry, a relation between u, v, mu1, mu2, and r. This relation is derivation is going to give me this. Okay, the relation between u, v, mu1, mu2, r. Any of this is not given in any one of the numerical, and in any numerical then you can use this kind of thing. Okay, let us erase this and let's go to the think about what here, which consideration we have taken over here. So you can see easily one more thing. Okay, we can get in this. How? So please do not write directly. In triangle, in which triangle you will be able to see this. So if you check the triangle, I'll just highlight and will show you. First of all, we are going to take a second. Understand this triangle. It's better if I draw somewhere. At it, so you can understand better. Okay, somewhat like this kind of diagram you can see on top. O, this one is like alpha, and this one is gamma. So I is the exterior angle. So in triangle, which triangle is it? So it is A, O. In triangle AOC, you can see this AOC. Which one is the exterior angle? I is the exterior angle. So exterior angle is always sum of these two. Okay, these two. Other than this one, okay, exterior matlab if you extend one line, any one of the line, if you are extending this one, then whatever the angle over here, that will be sum of other two, huh? Not this gamma, but other two. So you have learned this in like a 9th standard. We know that I is equal to alpha plus gamma. Why are we starting with I, all these things? So we are going to use Snell's law. Now Snell law says that sin I by sin r is equal to mu2 by mu1. As the light comes from the mu1 and going into mu2, so it is mu2 by mu1. This we know. So what about this I and r? How can I substitute this? So that is why we are considering one by one the other triangles. And in place of I and r, we are going to put this alpha, beta, gamma. Okay, and this alpha, beta, gamma, we are going to make 10, 10, 10 of something, opposite side by adjacent side. All these things we are going to do anyway. So the next is which triangle? So in triangle, you can see at this time, we are going to take Oh, actually, I already got I is equal to I is there. Okay. Now, what about the other R? When can I include this angle of refraction? So I need to see in that manner. So I can see that R angle of refraction is included in this triangle R and beta. But R and beta are located in one triangle only. Okay, that means I can see that gamma is at the exterior side. So I can take that minute. You can see it somewhat like this. You will be seeing. Okay? This is your R and this one is your beta. That means if you extend this line, and you can see over here, there is a gamma. So a gamma is the exterior angle, and that is how you can get R plus beta. So you can make R as a subject, gamma minus beta. So that is how we got I and R. Okay, I and R, angle of incident and angle of refraction in terms of alpha, beta, and gamma. But you know what? This tan alpha is already known. As you can see, okay, which triangle? Here we did not write the triangle. So which triangle was it? So it was A, C, I. Okay. In triangle AOC, I is equal to alpha plus gamma. In triangle ACI, gamma is equal to R plus beta. We made R as the subject and gamma minus beta. But in triangle, all these triangles, you can make this tan alpha. Tan alpha is opposite side by adjacent side. Tan alpha is opposite side by adjacent side. Right. So here you can see where is your tan alpha. So you have to see that particular triangle only. So alpha matlab this triangle. Okay, this triangle. Right angle triangle only we can take up. If you want to use a tan alpha, matlab it should be a right angle triangle. Other than that, we cannot use. Tan alpha is opposite side. Opposite side matlab MA by adjacent side. That is MO. Okay, but we have already in assumption in the previous slide, last class, we have already studied whatever angle is made by these things, okay, by angle of incident, angle of reflection, they are very small. If they are very small, this alpha, beta, R will be even smaller because the aperture curve is also very small. This curve is also very small. So that is how alpha, beta, and gamma is also very small. So in place of tan alpha, we can take only alpha, which will be like similar to MA by. Similarly, beta, can see beta. So for beta, which triangle we can take? So you can see, can you see this? So it is again a right angle triangle. Right angle triangle. So tan beta is equal to MA by MC, MA by MI, MA by MI, right? And that is how we can write beta is similar to MA by MI. Even for gamma also. Gamma is also again having this right angle triangle. And from that right angle triangle, which right angle, to yellow color, you can see I made a yellow color for that gamma thing. And we can see clearly it is MA by MC. And that is how gamma is also similar to MA by MC. Why so? Why I could use all this? So in the bracket, please mention that alpha, beta, and gamma are small angles. Okay. Then only we can take tan alpha is similar to alpha, tan beta is similar to beta, and all these things we can make. Chaliye. According to the Snell's law, take according to the Snell's law. What the Snell's law said? We have mentioned already sin I by sin r is equal to mu2 by mu1, right? So what is sin I? Sin I can be taken as I. Since I know assumption we have already done that angle of incident and angle of refraction are very small in these refractive surfaces. So that is how I can take I by R is equal to mu2 by mu1. Why so? What is the reason behind it? Since the I and alpha, okay, what is the reason behind it? Because I and R are small. Okay, this was assumption actually. So that means mu1 I is equal to mu2 R. But already we have I key value we have already on top. You can see I is equal to alpha plus gamma and R is equal to gamma minus beta. So if we substitute that, let us get this. Okay. Further, I cannot write directly, otherwise here so we have answer directly, but we are going to do it in detail. So let's go for that. Just now we got that it is mu1 I is equal to mu2 R. And mu1 I was actually alpha plus gamma and mu2 R is gamma minus beta. Yes.
I didn't copy the slides.
Yeah, do it. So you can write down the last, all this substituting for I, R, alpha, beta, gamma, replacing M by P and rearranging. How can we replace M by P? So that reason also we are going to give, no issue. Take your time. They are very small. What does that mean? If they are small, then sin I is similar to I and sin R is similar to this is the thing. And I, if I and R are small, then in that case, we can put like this. Yeah, okay. Don't write all this. Here we reach. So mu1 alpha plus gamma. I need to go back and because I have to substitute alpha, beta, and gamma. Alpha is nothing but Ma by Mo. Ma by Mo. Plus gamma is, no need to write this down part. Please do not write. We are doing derivation. Here it is not given. Derivation is not mentioned properly. So we are doing in detail. Because this was only for the revision purpose. So that is the thing. Ma by Mo. Beta is Ma by Mi. Always. Beta will be Ma by Mi. And gamma will be Ma by MC. This will be throughout so many derivation we are going to see. In all the derivations, we are going to do this manner only. Ma by Mo alpha, Ma by Mi beta, and Ma by MC gamma. Okay. So next you can see that Ma can be taken common from left hand side and we can cut. Okay, we can cut. Even Ma can be taken common at right hand side and we can cancel it out. So I can clearly see that Mo, but instead of Mo, I'm going to put Po directly. And why so, that also I'll explain you. Because you know what, assuming, we are going to assume M and P are close. M and P are close, so that means we can replace MO by PO. Why so? Because we have distances. As you can see in the diagram, we have distances from pole only, not from M. So we considered that M and P are very close. Okay, so that means OP can be considered as OP, PO, that is our object distance, and then PI will be image distance, and PC will be radius of curvature. So let's separate it. So mu1 by PO plus mu1 by PC is equal to mu2 by PC minus mu2 by mu1. I can take PC term that side, so it will be easy for us. In this case, mu2 by PI plus mu1 by PO is equal to, you can see, mu2 by PC minus mu1 by PC. But you know what? PO is nothing but your image object distance. PI is positive V, right? Image distance, right hand side, no? Image distance, positive, right hand side, positive. And PC is again right hand side of the pole, We are taking plus only, and that is radius of curvature. So it is mu2 by pi is positive v, and this is negative. Negative. So I am taking minus mu1 by u only because u is negative. Mu2 minus mu1 I can take common, and by PC will be same only, that way we can write, and that is R. And that is the thing. This is your answer. But if we have further, we can put one note. This is your answer, right? Suppose light refract from optically rarer medium to denser medium. And for the real image, convex refractive surface. So in that case, this will be your formula. Okay, mu2 by v minus mu1 by u is equal to mu2 minus mu1 upon r. If your first medium, suppose your first medium is air, that means suppose your mu1 is 1. First medium mu1 is air. Air के लिए refractive index is 1. So let me take mu2 as mu only. So it will be turned, this formula is going to turn into mu by v. It will be mu by v minus 1 by u is equal to mu minus 1 upon r. That case, this would be a final equation. If it is so, this is your case. This can be a now. Again, we can revise. Okay. Revise. Okay, we had this diagram. We had this diagram. We understood. Not we had diagram. We just had a point object which is lying on the principal axis. We took two rays. One ray is taken as the first ray is OA, and which is going to incident at point A. At the point of refraction, it occurs, it goes from rarer to denser medium. That means bending towards the normal. NC is your normal, and it is going to bend towards it, and that is how it is meeting at principal axis at I. And another ray is considered as OP, so it is like undeviated and goes directly to I, and that is how it is making angle of, sorry, it is a image I, it is considered as image, and that is how angle of incident we got, and angle of refraction also we got. Angle of refraction and angle of incident. Consider that alpha, beta, and gamma are the angles for object O, then image I, and radius of center of curvature. So from the exterior angle formula, we got that we got this relation. We made I and R. Always in each and every case, we are going to make I and R as a subject. I know that if I would have right angle triangle for 10 alpha, I can write opposite side by adjacent side. For 10 beta also, I can write opposite side by adjacent side. And for 10 gamma also opposite side by adjacent side. For three different triangles, I can get alpha, beta, and gamma. Since alpha, beta, and gamma are very small angles, we can write in place of 10 alpha, I can convert it into alpha. But agar Snell's law says that sin I by sin R is equal to mu2 by mu1. In place of sin I can take as I, since your angle I and R were very small, I can take in this manner, and that is how I got mu1 I is equal to mu2 R. Okay. but I need to substitute the values of I and R from this exterior angle thing. I substituted the values from the exterior angle thing, and that is how I got the formula in terms of alpha, beta, and gamma. But I had already alpha, beta, and gamma in terms of distances from the 10 thing, okay, opposite side by adjacent side. So I just substituted from left hand side and right hand side. MA was there in the numerator. So always we do not want this numerator. So we cancelled out this numerator to common and cancel, to common and cancel. Next step, we assume that P and R are very close. So I considered that MO is nothing but PO. Then MC is nothing but PC. MC is again PC and MI is P, because I'm and P are very, because you know what, next step we are going to put distances. PO is object distance, PI is image distance, PC is radius of curvature. So when can I put, if I would have distance from pole, not from any some point M? So that is why M and P are very close, and we converted all the distance from M to P. Okay, all the distances we took from P now. So that is how all PO and all are introduced. POPI we take left hand side, and PC we keep at the right hand side. Both PC are at the right hand side. We substituted the values. V and R are right hand side, positive, Q left hand side, negative. Note is like simple note. Mu1 is air. Suppose it is coming from the air to some refractive index mu. So in that case, that will be the new form. Let us go for the next derivation, refraction at convex surface. Again, convex surface. But this time we are going to draw for the virtual image. Rarer medium to denser again, but for virtual. Now for virtual, if you remember, it is like lens thing, right? We do not remember that when can we put so that we get a virtual image. So if you put closer, between like closer to pole, if you go further closer to pole, you will get this kind of image. So you are keeping your you're keeping your object near to pole. You're keeping your object near to, and when you keep your object near to pole, you will get virtual image, virtual and erect. You can turn that mirror table I had given you, so like it will help you. And later on we are going to do this, you will learn that part. I'll show you one trick also to remember all these things whenever we are not going to take so anyway, this is my, for this we are not going to write full description. You can write description your own. For all the things, half pages description is like taking too much time. Please mention rarer medium, denser medium, mu1, mu2. I'm helping out how to draw. Okay, this is your angle of, this is your incident ray, and this incident ray is going to fall on to this xpy surface, xpy surface on some point A. And we know that at some point A, we have some normal, and this normal always passes through the center of curvature. So I got my radius of curvature also, it's fine. And as it is going from rarer to denser medium, that means it is going to bend towards the normal, rarer to denser medium towards the normal. So actually the light should travel straight line like this, but towards the normal. That means the light will travel in this direction. But as it is virtual image, cannot show on the screen. If you extend in another direction, It is going to meet at this virtual image, appear to meet. That is how we draw our image, virtual image. Now what? We have to put angles. What is the angle of incident? So incident ray and normal makes angle of incident. Angle of incidence. And angle of refraction and normal makes angle of refraction. As I told you, one trick, always remember that your O will make alpha, your I will make beta, your C will make gamma. O, I, C. O, I, C. We say no that way. O, I, C. Alpha, beta, gamma. And what about image? Image, so we get two rays. No? So here another ray that we did not show. So another ray is directly in this. But we extend other side and we one more. One more thing should be taken, and that is normal. Why normal is required? To use 10 alpha, 10 beta. Who will help me out for the alpha? MA by OM. Same thing. MA by OM. Whatever we did that only. MO. Then beta for beta, MA by MI. For gamma, MA by MC. For all the derivations, this alpha, beta, or gamma are going to be the same. Then what will be the change? Exterior angles will be the change. The relations between exterior angles are going to be get changed. Otherwise, everything is the same manner we are going to derive. What about your image object distance? U. Image distance with P only. We can take V and R. And that is how you're going to complete your diagram. You need to write further things. Okay, write that long method. We are directly starting with the exterior angle. Okay, here it is not given, but I'll give you this derivation at least. I'll give later on, we can do directly. So, in which triangle you can see, in triangle, for what we are writing this, so we have to see that for a relation of I, we have to make, I am going to use this sin I by sin R is equal to mu2 by mu1. And then it will be like I by R is equal to mu. That means I and R should be written in terms of alpha, beta, and gamma. Okay, that means I want a relation. I want to remove this I and R and put alpha, beta, gamma. So you can see that it is this I is made if we extend this line. So you can see that I is the exterior angle and alpha and gamma can be added for that. In triangle AOC, I is equal to alpha plus gamma. And in triangle, I want R also. So R, if you extend this, so I will get, yes, I'm getting this full big triangle if you take this big triangle. Will be an exterior angle of this. I can see it easily. A, I, most of these you are going to take AOC and AIC. Remember this also. AOC and AIC. AI R is equal to beta plus gamma. Now as we know कि by 10 alpha is equal to, we know this, okay, opposite side MA by MO. That means alpha is similar to MA by MO. Then 10 beta is equal to, always beta will be with I, O, I, C. So MA by MI, O, I, O, I, and then it will be C only. C. Okay. So gamma is equal to MA by. Why we could take this manner? Since alpha, beta, gamma are very. So by Snell's law, sin I by sin R is equal to mu2 by mu1. I by R is equal to mu2 by mu1. How can I do this? Since I and R are small, then sin I is similar to I and sin R is similar to same ditto copy previous one. So it is like mu1I is equal to mu2. Let us substitute this I from top. I is alpha plus gamma is equal to mu2. R is beta plus gamma. What do I do with this? So I have relations alpha, beta, and gamma. Let us substitute everything. Alpha is Ma by Mo. OIC. Gamma is C. Beta is MI. Ma by MC. You can see that Ma can be taken out common in left hand side and even in right hand side, and we can cancel them out. Ma got cancelled. Whatever leftover part, let us write on. I'll write on next page. Please complete this. So the next says that what do we have to do? Where were we? Ma got cancelled. So mu1 and it was Ma got cancelled. No? नीचे अल्फा मतलब O plus I need to see this. O fine. But the next we know that I can M and P are close, so I could have done that also along with it. 1 by PO plus 1 by PC, as we want to substitute the distances, and distances, object distance, image distance, and all the distances are to be taken from the pole. So that is why we had to replace M by P. So let us substitute, and I know that PO is the left hand side minus U, object distance, EI left hand side virtual image distance, and PC is positive R. It is radius of curvature. 1 by minus u minus plus 1 by r is equal to mu2 1 by minus v plus 1 by. Let me take both r thing that side. I am keeping u and v terms. Let us take one side only. So if mu2 by v comes, then it will become positive at left hand side. And mu2 by r minus mu1 by r. So the equation is mu2 by v minus v1 by v, mu1 by u. If you compare the previous one, no, you will not find any change. This was the same diagram. Sorry, this was the same formula you got. So whatever it is, when light travels from optical rarer to denser medium for convex refractive surface, you'll be getting in this manner only. mu2, matlab formula will remain the same. mu2 by v minus mu1 by u is equal to mu2 minus mu1. That is for virtual image or real image. Both give you the same. So that was it. We can see further because heard all the classes today, huh? Okay, able to explain a little bit of that. So let us go before slide. Yeah. Now onwards, I'm not going to. We are not going to derive all the things. We are going to just write down the formula. As you know that whatever the, if you know the diagram, you can easily make your derivation. So no need to go further in this part. Okay, refraction at concave surface. So how do we do the refraction of concave? We are not going to derive everything, but you know it is the same method you can derive. Okay, so this derivation will be your homework, but you have to draw the diagram. What is it? The refraction at concave surface. It is same. It looks little jumble. Okay, what is this? But the formula will be the same. It's just you need to identify what will be your this exterior angle and all. So that part I am giving you the hint. Okay, that part I'll give you. When that you can take. So let us understand this refraction at concave surface. So you can see the surface is changed now. Surface xy is changed, and this time we have concave. Rarer to denser medium, mu1 to mu2. And we are getting virtual image. So virtual image matlab at the same side we are going to get in erect form. So that means for this kind of, if we have object at this point, and you can see that when do I get image also this side. So it goes in the one medium to the another medium, it has to go in this manner. But as it is going in refraction, the rarer to denser medium, away from the normal. Where is the normal? So understand this point very clearly. This side, the surface is like this. Okay. Okay. That means your center is somewhat over here. So whenever you are going to draw a normal, now this time normal will be this side, not the other side. For this kind of surface, your normal will be meeting center of curvature at left hand side as your object is. So that is how you are getting center of curvature left hand side for this purpose, as you know that. And normal towards the normal. What is your normal? So normal is like this one is your normal at point O. So towards the normal matlab it will go towards this side. You can see the blue arrow. So this side it bends, and that is how this is your angle of refraction. What is your angle of incident? So with the normal and object ray, sorry, yeah, that angle of incident ray, I and R. Yes. So we had to find out, we had to get the relations. So in that triangles only, we always take NOC and NIC. In triangle NOC and sorry, we have taken A. Okay, AOC was A. AOC and AIC. So A O C. One can see that I and R. This is your I. This one is your alpha, and this side is extended, which is giving me gamma. So that means your gamma is equal to alpha plus I. So you have to make I is equal to gamma minus alpha this time. So whenever you need to substitute sin I by sin R, you will put gamma minus I by R. R we will find now. AIC. There is I. I'll take another color, blue color, green color. Then AIC. Okay. Small AIC. I is beta. This one, if you extend, it is gamma. And you know what, which angle we want actually. So you can see it is R, because you know what, here we got I, so I need to have R. R should involve, otherwise there would not be any point of getting this. So in this case, I can see that if this is R, no, this will be also R. So that means that this is also R, and gamma is equal to beta plus R, and R is equal to gamma minus. So that is how we got alpha and I and R. And further, everything will be remaining the same part. It's just whenever you will put I and R will be different. But you are going to arrange in this manner. Radius of curvature will be right hand side, other things will be left. This will be your homework. This question was asked question. So make sure it is not your MCQ paper, it is descriptive paper. This is going to be your homework. But you know what? Ultimately, your answer will be the same. Okay, we don't write in this manner. It is the students are finding difficult to remember in this manner. My trick is mu2 by v minus mu1 by u. This is easy. I guess you people find this one easier than the above one, because sometimes it happens that you forget putting minus sign with u and okay. So in all the cases, we are getting the same formula by this. That is how it is. Last refractive, we are going to suppose that was only for virtual. Only virtual was there. For concave, only virtual was there. What happens if we have both the surfaces for like denser to rarer? We have seen 3 cases. Okay, 2 derivations I showed you. Third one is in homework, and now we are going to take only directly. No homework, but directly you're going to remember. Okay, denser to rarer. Suppose it is denser to rarer, then what happens? So denser to rarer, that means you're going to put your object at denser side, and you're going to get your image accordingly, your real image then at rarer side. If your like virtual image, then it will be at denser side only. But suppose for real image you're getting, so what will be the final formula? Just remember the formula. Mu2 by u. This time what was it for the rarer to denser? Rarer to denser throughout concave or convex, you had only one formula. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. But you know what is the change with this and that? You can check that it is just mu1 and mu2 are replaced. You can see that it is mu2 by minus u. That means your new formula, you are not going to write in this manner. You're going to write in this manner. Mu1 by v minus mu2 by u is equal to, now you will write as like mu1 by, yeah, this is right. Mu1 minus mu2 by 1 minus mu this time. Okay, so it's just, you're going to remember that way. Okay, whenever it is rarer to denser, our normal formula. But if it is denser to rarer, then replace your mu1 by mu2 and vice versa. Even for like a virtual image, virtual matlab at the same side if you get, then also this is your formula. Virtual image, if you're denser to rarer, the same formula. You can see that this is the normal formula now for all the denser to rarer media. Refraction for the concave also, for virtual. Concave may only virtual, okay? You don't have like this image or real image, you don't have only for concave. Concave, you do not have that. If it is there, no, I will check. It is not there only. You have both the rarer to denser also. You have virtual image, and denser to rarer also. You have virtual image only. Okay. There is no confusion. Do not worry. Like this only. Anyway, you can take a screenshot. Otherwise, I'm going to put on YouTube, and you can, if you know something is there, you can take screenshot there, and you can complete your diagrams. But remember that you're going to remember in this manner only. Don't try to remember this. Not so good to remember. The yellow color. I made that box on. Note, expression for optical to optical in object in rarer media is the same whether it is real or virtual image or convex or concave surface. All are having same formula. We are not going to remember in this manner. We are remembering mu2 by v minus mu1 by u is equal to mu2 minus mu1 by. It was little difficult me to change this, so I could not change. I could not get chance to do so. Otherwise, I would have done this. We are not going to remember in this manner. Mu1 by v minus mu2. You can see that I'm just replacing the top formula mu1 by mu2 and mu2 by mu1. If it is denser to rarer, just replace mu1 and mu2. That's it. And u, v, and r must be taken with the proper sign. If it is pole left hand side, then the left hand side of the pole we take u negative. Always u will be mostly negative only. V and r accordingly. Virtual image v negative. R for concave it will be negative. Otherwise for concave, convex, positive. That way we take. And the refractive indices mu1 and mu2 get interchanges in the expressions, and that's the simple logic. So that's it for the class, and I guess next example is like related to this only. So let us do one example, because this is like directly from the textbook, and it is, we are going to use this funda only. A light from point object matlab, yes, light from a point source, that means this only. Spherical glass surface, and n is given 1.5. So that means it is coming in air, falls on some glass. Okay, that means air, that means 1, and falls on the glass, mu2 is 1.5. Radius of curvature, which is 20 centimeters. Okay. It is not given which kind of surface is it, but it is given positive 20. spherical glass surface. It is not mentioned that which kind of spherical. Convex. Let us take convex. The convex, because it is given plus 20. The distance of the light source from the glass surface is 100 centimeter. Light source, source matlab ye object. Object distance is given. Object distance always take negative. Here in this kind of question, we don't lens question and all, we do not convert centimeter to what position image is for. V is to be found. This is like ditto that formula only we have. Mu2 by V minus mu1 by U. Rarer to denser, the normal formula. Rarer to denser. Normal formula. Mu2 is 1.5, V is to be found. Mu1 is 1 by U is minus 100 is equal to 1.5 minus 1 upon R is 20. So we need to find out V. Okay. करना पड़ेगा इसमें तो. Anyway, it is like 15 by 10 V and plus 1 by 100 is equal to 0.5 by 20. 0.5 by 25. We got positive, that means the image is at the side, other side of the surface, that means it is real image, right? Real. What is the position? What position the image is for? 100 centimeters.